Have you ever heard the term linked list and just felt your brain start to shut down? Well, you can forget all that. In this explainer, we are going to break it down piece by piece, and I promise you, by the end of this, it's going to be one of your favorite topics. So here's the game plan. We're going to start with the absolute basics, a simple building block, and then we're going to see how it all clicks together to create this super powerful data structure. Let's get started. All right, first things first. Before we can build a chain, we have to understand what the individual links are made of. And that special ingredient comes from the C programming language. So think of a struct as a way to invent your own data type. You know how an integer just holds a number? Well, a struct is like a custom container you design. You can say, I want my new variable to hold a number and some text and something else, all bundled up together. Now look at this code. We're not actually making a variable yet. We're just drawing up the blueprints. We're basically telling the computer, hey, listen up. I'm inventing something new called a struct item. And anything that is a struct item will have a spot for an integer and a spot for a pointer. And then, when we actually go and create one of these struct item variables, the computer carves out a single chunk of memory just for it. But inside that chunk, you've got these neat little compartments, one for the integer and one for the pointer, just like we planned. Okay, now we get to the part where everything changes. This is the big idea, the aha moment that makes linked lists even possible. And it all starts with one simple game-changing question. Think about that for a second. In our last example, the pointer just pointed to a plain old integer. But what if the pointer inside our struct could hold the memory address of another identical struct? What if it could point to a copy of itself? And boom, here's how we do it in code. We've defined a struct node. It's got an integer for data, sure, but look at that second part, struct node star. Next, that pointer isn't pointing to an int, it's a pointer to a struct node, the very thing it's inside of. It's literally designed to find its own kind. And this, right here, is the secret sauce. The type of the pointer is everything. Because that next pointer is specifically a struct node pointer, it gives one node the ability to point directly to another one. It's how we're going to form our chain. Okay, so we've got our blueprint for this awesome self-pointing container. Now it's time to actually fire up the factory and create the very first piece of our linked list. And we have a special name for this little building block. It's called a node. That's all it is, a single instance of that self-referential struct we just designed. So every single node we make is going to have two parts. It's got the data field, which is where we put our actual information, and it's got the next field, which is like a hook, just waiting to hold the address of the next node in the sequence. So we have our individual nodes, our building blocks, but right now they're just scattered. They're like a pile of Legos not connected to anything. So how do we actually snap them together and forge a chain? Well, the logic is actually beautifully simple. We make two separate nodes, let's call them S1 and S2. Then we find out the memory address of S2, and we just store that address inside the next pointer of S1. That's it. So at first, this is what it looks like in the computer's memory. Two completely separate boxes. They each have data, they each have a next pointer, but they have no idea that the other one even exists. And then, with that one simple line of code, bam! We've created a connection. We've drawn a logical arrow from S1 to S2. S1 now knows exactly where S2 lives. We have officially forged a chain. That's great. We have a chain. But what's the point if we can't move along it? So how do we actually travel from one node to the next to see what's inside? Now, this is a huge difference from something like an array. In an array, all the elements are lined up neatly in a row in memory. You just go to the next address. Easy. But in a linked list, these nodes could be scattered all over the place. The only way to get to the next one is to look inside the current node's next pointer and follow that address. It's like following a breadcrumb trail. And here's a super important little piece of syntax you gotta know for C. If you have the actual struct variable itself, you use a dot to get its data. But if you have a pointer to the struct, which is what we'll be using to move down the list, you use this cool little arrow operator. It's just shorthand that means follow this pointer, then give me the data. We can build a chain that's 1,000 nodes long, but no matter what, in every linked list, there is one single pointer that is more important than all the others combined. It's our one and only entrance. We call this special pointer the head. Now, it's really important to get this. The head is not a node. It doesn't hold any data, it's just a simple pointer. And its only job is to remember the memory address of the very first link in our chain. And this is why it is everything. If you lose the head pointer, the entire chain of nodes is just lost in memory. You have no way to find it. It's like losing the only key to a treasure map. Every single thing we do, reading the list, adding to it, deleting from it, it all has to start at the head. If head is empty or null, that tells us the list is empty. So why go through all this trouble? Let's bring it all home. An array is static. You set its size and it's fixed. Its order comes from being laid out in memory one after the other. But a linked list, it's dynamic. It's alive. Because the order is maintained by pointers, we can add and remove nodes whenever we want, and the structure can grow or shrink to fit our needs. That's its superpower. And that leaves us with a final question to think about. We know how to build a list and how to walk along it. But the real magic comes next. How do you carefully rewire those pointers to insert a new node in the middle or pluck one out without breaking the entire chain? That is the next step to becoming a master of this amazing data structure.